about the electric field due to the ring, why don't we ask a couple of follow-up questions, things that could be interesting. Let's ask, what is the field of the center of the ring? There's a couple of ways you could answer that. If we look at this as being a charged positive ring, this is going to make an electric field that points this way. Here is going to make a field that points this way. Here makes a field points this way. Here makes a field that points this way. Due to the symmetry of the whole ring, that electric field at the center is going to be 0 because every charge on this side cancels with a charge on this side. They cancel at the center. So if we want to know the field at the center, we could answer that at 0 due to symmetry, or we could use our equation. E at x equals 0 equals k times 0 times q over a squared plus 0 squared to the 3 over 2 equals 0. So the math backs it up that the field at the center is 0. So we know it's 0 at the center, so it's 0 in here. It's 0 when we get far away, so that means it must increase to some maximum value and then decrease again. That would be an interesting graph to draw. So if it goes from 0 here, 0 here, it has to go to some maximum. Let's see if we can sort out where the maximum value is. So let's answer that question next. Where is the field a maximum, and what's the value of that maximum field? So here's where we have to apply a little bit of calculus. If we want the field to be a maximum, we know that the first derivative is going to be a 0. That gives us the extrema of the field. So dx dx equals 0 gives the extrema, the maximum and the minimum. So we'll take our derivative and we'll set that equal to 0. So let's find the derivative first. Okay, so there's our x component. So we want to do d by dx of k times x times q over a squared plus x squared to the 3 over 2. A little bit tangly, but not the end of the world. So we'll take our k and our q outside, doing d by dx of x over a squared plus x squared to the 3 over 2. And let's do that derivative. You can do the quotient rule. I'm a fan of the product rule. So product rule means we're going to do k times q d by dx of x times a squared plus x squared to the minus 3 over 2. Product rule I seem to remember, quotient rule I always forget. So product rule means we take our kq, that's outside of everything. So we take the derivative of the first part and we multiply it by the second part. Derivative of x is just 1. So we have a squared plus x squared to the minus 3 over 2, or 1 over 3 over 2. And then we're going to add that to this term, x, times the derivative of this term. The derivative of this term is minus 3 over 2 times the argument, a squared plus x squared. This goes down by 1, applying the power law. So minus 3 over 2 take away 1 is minus 5 over 2. Then we multiply, going to use our chain rule, by the derivative of what's inside, which is going to be 2x. Okay, so there we have that. Let's see if we can simplify a little bit. This 2 is going to cancel with this 2, and that looks like all we can do there. So we have k times q times 1 over a squared plus x squared to the minus 3 over 2. And then here we have minus 3. Then this x times this x gives us x squared. On the bottom we have x squared, a squared plus x squared to the 5 over 2. And let's see if we can make that a little bit nicer. Let's get the same exponents down here. Let's multiply top and bottom by a squared plus x squared. K times q, a squared plus x squared over a squared plus x squared to the 5 over 2 minus, this guy's okay, has the same denominator, a squared plus x squared to the 5 over 2, brackets around there. Now let's see what we have. We can add these two guys, so we get a squared plus x squared minus 3x squared gives us k times q times a squared minus 2x squared over a squared plus x squared to the 5 over 2. So there's our derivative. dEx by dE. We said we're trying to find the maximum. We know the extrema occur where that's equal to 0, so we want to find out for what x value is this derivative equal to 0. So we can get this equal to 0, definitely at x equals infinity, so we get a big infinity on the bottom, small infinity on the top, so that'll go to 0. That's kind of boring. So we get a minimum for x goes to infinity. This can also be equal to 0. Where else? If our numerator is equal to 0, so we get a squared minus 2x squared equals 0. This would give us x equals a over root 2, and then that's going to be our maximum. So doing our derivative tells us that we get a 0 here. We know it's going to be a maximum because it goes through a maximum. If you wanted to test it, you could do the second derivative test. Okay, and last, we asked what is the maximum field. So let's put this value of x in our expression for Ex, and let's see what we get for our electric field there. So maximum field E of x equals, put in our values, k times our x value, which we said was a over root 2, times q over a squared plus x squared, a over root 2 squared, and that's to the power of 3 over 2. And we can simplify that a little bit, and what we do when we get our answer is 2 times k times q over root 27 times a cubed, so you can work that out. So there's what our maximum field is. E equals 2kq root 27 a cubed in the x direction. Those last two questions, definitely a little bit challenging. This one's not so challenging. You should be able to know what the field at the center is. Where is the field of maximum and what the maximum field is. That might be a little bit rough on a test, but it is definitely something you should be able to do if you have a little bit of time to sit down and think about it.